Hello boys and girls, this is Miss Coville and this lesson is for all 5th graders at Bethune Elementary. I'm teaching this lesson today on classifying two-dimensional figures to students in both my class and Mr. Moore's class. Please make sure you stop and jot notes as you view this video. Today's standard MS-GE5 G4 says that students will classify two-dimensional figures in a hierarchy based on properties: polygons, triangles, and quadrilaterals. By the end of this lesson, it is expected that you'll be able to create diagrams classifying 2D figures. Throughout this lesson, you will hear me use words such as acute, obtuse, right angle, parallel, perpendicular, and parallelogram. Please be sure to write down or highlight all words that have definitions such as parallel, parallelogram, acute, and right angle. Also make sure you jot down all notes and pause when needed. Let's get started. Our first question tells us to study the example problem that shows how to sort shapes based on parallel and perpendicular sides. Then we will solve problems 1 through 6. So we're going to mark each shape that appears to have at least one pair of parallel sides with a symbol such as this one right here. And we're going to mark each shape that appears to have at least one pair of perpendicular sides with a symbol such as this. Parallel sides are always the same distance apart and will never cross. And perpendicular sides form a right angle, which is 90 degrees. It tells us to look at the shapes in the example, and we're going to write the name of the shapes that belong in each group shown in the table below. And in our table below, we need to identify which of our shapes above have parallel sides only, perpendicular sides only, parallel and perpendicular sides. So we have a triangle. Now, all of our sides to our triangle touch one another. So we don't have any parallel sides, neither do we have perpendicular sides because none of our angles create a 90-degree right angle. So our triangle will not go into any of our categories. Let's go ahead and look at our rectangle. Our rectangle, I see that I have one pair of parallel sides because these two sides do not cross. And I see I have another pair of parallel sides and they don't cross. And I also see that I have a right angle. I have 4 right angles because my perpendicular sides form a right angle. So that means my rectangular shape will go in parallel and perpendicular sides because I see I have a parallel sides as well as perpendicular sides that form a right angle. So let's go ahead and write that in this space right here. Now let's move on to our parallelogram. I see that I have one pair of sides that are parallel that do not cross. And I have another set of parallel sides that do not cross. But I don't have any perpendicular sides because I don't see any right angles. So my parallelogram will go into my parallel sides only. Now let's take a look at our trapezoid. I have one pair of parallel sides. They do not cross. And I have another pair of parallel sides that do not cross. And all of my angles are not perpendicular because they do not make a 90-degree angle. So both my parallelogram and my trapezoid will go in my parallel sides only box. So let's go ahead and we're going to write that down now. Make sure you press pause and write it in your space below. Now let's take a look at our right triangle. Now my right triangle, all of my sides cross one another, so they have no parallel sides, but I do have a perpendicular side where these two sides form a 90-degree angle. So that means my right triangle has perpendicular sides only, and I can write that down in this column. So again, the shapes that have parallel sides only will be my parallelogram and my trapezoid because they do not form a 90-degree angle, but they do have sides that do not cross. they have parallel sides. My perpendicular sides only will be my right triangle. I have no parallel sides, but I do have a perpendicular side that forms a 90-degree angle. And parallel and perpendicular sides will be my rectangle. Go ahead and make sure that you have these copied down in your chart. And let's move on to question 2. 2 says, which group from problem 1 does each shape shown below belong in? So we're going to look at each of our shapes right here, and we're going to see which column would we place them in. So for our first shape, I see I have one pair of parallel sides right here. Then I have another set of parallel sides right here, and another set of parallel sides right here. But I don't see any right angles or perpendicular sides. So that means for this shape right here, I would put it in the parallel sides only. So let's go ahead and write that below. So I know that this shape would go in parallel sides only. Now let's take a look at this shape. So I see one set of parallel sides and I see another set of parallel sides. Now I also see some right angles, which means I have perpendicular sides as well, because I see a right angle right here. I see a right angle right here. I see a right angle right here and right there. So that means this shape would go in my parallel and perpendicular. Let's go ahead and write that down. Parallel and perpendicular. Make sure you're writing these answers in your packet. Now let's move on to question 3. It tells us to draw a shape that does not belong to any of the groups in problem 1. So that means our shape will not have any parallel sides or perpendicular sides. So press pause and draw a shape that will not belong in any of the groups in problem 1. So a possible shape that you could have drawn is a pentagon. So I've drawn a pentagon, and a pentagon has 1, 2, 3, 4, 5 sides. And my 5 sides, I do not have any right angles, nor do I have any parallel sides. Now let's move on to our next question. So question 4 says, finish marking each angle in these shapes. A for acute, R for right, and O for obtuse. Now let's take a look and see what these terms actually mean. So a right angle is an angle that looks like a square corner and measures 90 degrees. So we have an example right here of what a right angle would look like. So when we're looking at our shapes, we're looking at corners that look just like this, that show a 90-degree angle, where you could have potentially put a box in the corner or a square, draw a square in the corner. So an acute angle has a smaller opening than a right angle. So if we look at our example right here, we see an example of an acute angle, and our angle is smaller than our right angle. Now, this is not the only example of an acute angle. If you look right here, this could be an acute angle. This could be an acute angle, or even this could be an acute angle, because as you can see, all of our lines are much smaller than our right angle. It's less than 90 degrees. So either one of these are an example of an acute angle. Now, an obtuse angle has a wider opening than a right angle, but it is not a straight line. So an obtuse angle goes beyond our right angle. So this is an example of a right angle, of an obtuse angle. This could be an example of an obtuse angle because it is just a little over 90 degrees. And this is an example of an obtuse angle because it's not a straight line, but it's pretty close. So these are all examples of an obtuse angle. So for our question 4, we're going to finish marking each angle in these shapes, whether it's A for acute, as we saw right here in this description, if it is R for right, which we saw right here in this description, and if it is O for obtuse, which we saw right here in this description. So for our first example, we have 2 of our responses given to us. So our first answer, we see that our first angle right here is acute because this angle is less than 90 degrees. Now I'm going to look at this angle right here. This angle looks obtuse because if it was 90 degrees, my angle would have been right here. My line, if it was 90 degrees, my line would have been right there. But my line goes beyond that. So this will be obtuse. So go ahead and mark O in that angle right now. Now let's go ahead and look at this angle right here. This angle is acute because let's go ahead and show what 90 degrees would look like. So if this were to be a 90-degree angle, my line would be right here. But my side, the line of my angle, is inside of here. So it is acute. It is smaller than my 90-degree angle. So go ahead and write A in that corner. And then as we see for our last example, we have O for obtuse. And let's go ahead and check just to make sure that it is correct. So I'm going to draw a line as if it were to be a 90-degree angle. And my 90-degree angle line will be right there. And as I can see, my angle is past my 90 degrees. So this will be greater than 90 degrees, which is an obtuse angle. Let's go to our next shape. So I see right here that I have a 90-degree angle, and it looks just like my example right here. So this angle would be right angle. So I would put an R in that corner because this is a right angle. Now let's look at my next corner. Now if I were to have a 90-degree angle in this corner, let's go ahead and draw what that 90-degree angle would look like. This will be a 90-degree angle. But I see that my angle is much less than 90 degrees. So I know that this is an acute angle. So I'm going to write A in this corner for acute. And we're going to do the same thing for our last angle. I'm going to draw a line as if it were to be a 90 degree. Now this is what 90 degrees looks like. But my angle is, again, much less than 90 degrees. So that means it is acute. So we're going to write A for acute in this corner. Let's move on to our last shape. Again, I'm going to draw a line to show what 90 degrees looks like. And then I will see, this angle is a little less than 90 degrees. It looks a little like 90 degrees, but it's not quite. So that means this will be acute. I'm going to write A for acute. Let's go to my next angle. Again, I'm going to draw a line where my 90 degrees will be. So this will be my 90-degree angle. But my angle goes beyond 90 degrees. So that means my angle is larger than 90 degrees, which means it's obtuse. So I'm going to write an O in this column, in this angle. We're going to do the same thing for our other side. We're going to draw a line. It's going to show us where 90 degrees would be. And this is what a 90-degree angle would look like. But my angle is a little less than 90 degrees. So this will be acute. So let's draw an A in this angle. And then let's do our last one. Or draw a line where 90 degrees would be. And my angle goes a little beyond that. So that means it's greater than 90 degrees, which means this is obtuse. Let's write no in this corner. Boys and girls, make sure you pause the video now and document and write all of your answers in its correct space. Alright, question 5 says, write the name of each shape from problem 4 that belongs in each group shown in the table below. So we have a table, and we're going to place which shape has acute and right angles, and which shape has acute and obtuse angles. So if we look back from our previous page, we know that this shape is a trapezoid, which I have labeled below. I know that this shape is a right triangle, which I label below, and I know this shape is a parallelogram, which I label below. And again, we know this based off of our previous page. So I see that my right triangle has 2 acute angles and a right angle. So I'm going to write right triangle in this column. And I see that my trapezoid has 2 acute angles and 2 obtuse angles. And I also see my parallelogram has 2 obtuse angles and 2 acute angles. So I will put them in this column right here. So make sure you write this down in your packet. So now we're going to read question 6. It says, where does each shape belong in the Venn diagram? And we have a Venn diagram right here. Write the letter of the shape in the section that it belongs in. So we have 4 shapes, shape A, B, C, and D. And we're going to place each shape where it belongs in our Venn diagram. So let's look at shape A. So I want to look at shape A, and I see that I have 2 pairs of parallel sides. So I know that it's going to go around this area right here. And I also see that I have acute angles. I have one acute angle right here, and I have another acute angle. So I know that I'm going to place my shape A in this part of my Venn diagram because I have both parallel sides and an acute angle in shape A. And my acute angle and parallel sides Venn diagram, this is where it overlaps. So I will put my shape A right here in this section. Now let's look at B. Now for B, I don't have any parallel sides, so I know that my shape will not go down here in my Venn diagram. But I do see a right angle right here, and I do see that I have 2 acute angles. So that means I have a right angle and I have an acute angle, and this section right here is where the 2 overlap. So I know that my shape B will go in that part of my Venn diagram. Now let's look at C. So for C, I see that I have 1 pair of parallel sides because they do not cross. And I also see that I have a right angle right here. And I also have an acute angle. So that means C has every single description in my Venn diagram. So let's find the place in my Venn diagram where all 3 of my circles overlap. And it looks like it's right here because parallel sides, acute angle, and right angle all overlap in this small section right here. So my shape C will go right here in this small section of my Venn diagram. Now let's look for D. Now for D, I see that I have 1 pair of parallel sides right here. And I also see that I have 2 right angles. But I don't have any acute angles. I do have an obtuse angle, but I don't have any acute angles. So that means D would go right here where parallel sides and right angle overlap. So let's put D right here. Make sure you press pause and fill in your answers, and let's move on to the next page. A hierarchy starts with the most general category and then shows how more specific groups are related. We're going to draw a tree diagram relating the shapes in the table. So we have our shape and we have our description. So a plane figure is a two-dimensional shape. We know a polygon is a closed plane figure with straight sides. I know a triangle is a polygon with 3 sides. A quadrilateral is a polygon with 4 sides, and a pentagon is a polygon with 5 sides. Polygons have all the properties that plane figures have. Polygons also have properties that plane figures don't have. Polygons appear right below plane figures in the hierarchy. Triangles, quadrilaterals, and pentagons have all the properties that polygons have. They have other properties too. Because triangles, quadrilaterals, and pentagons have different properties from each other, they appear side by side. So that means I know that a triangle, a quadrilateral, and a pentagon are polygons, and they're also plane figures. But they have their own separate properties, which is why they're side by side. So a triangle is a polygon, and it's also a plane figure, but it does not have all of the exact same qualities as a quadrilateral or pentagon, which is why it is next to it. So question 1 tells me to fill in the blanks. Triangles are both what and what. So as I stated before, triangles are both polygons and plane figures. So let's write that down. So as I can see in my tree diagram, a triangle is both a polygon and a plane figure. Let's move on to question 2. Question 2 says, a circle is a plane figure. And we stated before, a plane figure is a two-dimensional figure or two-dimensional shape. But it does not have straight sides, so it is not a polygon. Where in the hierarchy should circles go? So I know that a circle is a plane figure. So I can put a circle underneath this category. But it's not a polygon. So that means I cannot put a circle underneath polygon with triangles, quadrilaterals, and pentagons. So that means I would put circle next to polygons because I know that it is a plane figure, but it would not go under the polygon category. So I would draw a line right here, and then I would make circle go next to my polygons because it is a plane figure underneath this category, but it is not a polygon. So we'll go in a category by itself. So let's go ahead and write that in complete sentences. So I know a circle is a plane figure. So it should be under the plane figure category, but it is not a polygon. So it will go in the same row as polygons, just as we had described previously. Let's go ahead and make sure we have this written down and turn to the next page. So number 3 tells us to mark an X in the column if the shape always has that property. So we have our 3 shapes: parallelogram, rectangle, and quadrilateral. And if you look to the right of our screen, I have an example of what these shapes look like. So we have a parallelogram right here, a rectangle right here, and a quadrilateral at the bottom. We're going to see if our parallelogram and our rectangle and quadrilateral all have 4 sides. So we see that our parallelogram does. It has 1, 2, 3, 4 sides. Our rectangle has 1, 2, 3, 4 sides. And my quadrilateral has 1, 2, 3, 4 sides. So I can mark a check in all three of these categories because they all have 4 sides. So I can mark a check in each of my boxes because I know that they all have 4 sides. Now let's move on to the next category. 2 pairs of parallel sides. Now again, remember we said a parallel side are sides that are the exact same length that will not cross. So I see my parallelogram has 1 pair of parallel sides, and I see that it has another pair of parallel sides, so that it makes 2 pairs of parallel sides. So I'm going to put an X for my parallelogram. My rectangle, I see that I have 1 pair of parallel sides that are the same length and don't cross. And I have another pair of parallel sides. They are the same length and they do not cross. So again, I have 2 pairs of parallel sides. So I can put an X for my rectangle because that fulfills that requirement. And my quadrilateral, let's see. So I don't have a pair right here, but I do see 1 pair of parallel sides. They're the same length, but they do not cross. So I only have 1 pair, but I do not have 2. So I cannot put an X for my quadrilateral. Now let's look for the shapes that have 4 right angles. My parallelogram. I see an acute angle. I see an obtuse angle, an acute angle, and another obtuse angle. So I do not see 4 right angles. My rectangle. I see 1, 2, 3, 4 right angles. So I can put an X in that one because my rectangle fulfills all of those requirements. And my quadrilateral. Let's see, I see an acute angle. I see an obtuse angle. I see another obtuse angle. And I see another acute angle. So my quadrilateral does not have 4 right angles. So your table should look as follows. 3. To make a flow chart that shows the relationship between the 3 shapes, order the shapes from general to specific, going from left to right. So remember, the most specific would have all 3 of the criteria within it. The most general would have the least amount of criteria. And then the one in the middle will have some. It will have a little bit of the most general, but it will not have all. So let's see. So our parallelogram, we'll start with parallelogram. Does our parallelogram fulfill all of the properties? 4 sides, 2 pairs of parallel sides, and 4 right angles? It does not. A rectangle, does it fulfill all of the 3 properties? 4 sides, it does. 2 pairs of parallel sides, it does. And 4 right angles, it does. So my rectangle would go right here because it's the most specific. So I would put rectangle because it fulfills all 3 of the properties. Now my parallelogram, it fulfills 2 over the 3. So I will put parallelogram right here. And my quadrilateral only fulfills 1 of those properties. So my quadrilateral will go here. So that means a parallelogram is a quadrilateral, but it is not always a rectangle. But my rectangle will always be a parallelogram, and it is always a quadrilateral. Now let's move on to question 5. Now question 5 says, where would you include squares in the flowchart in problem 4? And explain. So I know a square is pretty much the exact same thing as a rectangle. So a square does have 4 sides, so it fulfills that property. A square has 2 pairs of parallel sides. It will fulfill that property. And a square has 4 right angles. So I would put my square to the right of my rectangle. So I would put a square to the right of my rectangle. square would go right here. Because my square is a parallelogram and it is also a quadrilateral because it fulfills all three of my properties just like the rectangle. So let's go ahead and we're going to explain that in the space below. Press pause and in your own words explain why would we put a square to the right of the rectangle. So our answer should state squares would go to the right of rectangles in the flow chart because they have all the properties of quadrilaterals, parallelograms, and rectangles. Make sure you have that written in your packet. Now let's move on to the last question. We are going to fill in the Venn diagram that shows the relationship between rectangles, right here, squares, and rhombuses. Explain what the diagram shows about the squares. So I have an example of a rectangle, a square, and what a rhombus looks like. So if I look at my pictures, all three of them pretty much have the exact same qualities as a square because I have two parallel sides and I have two pairs of parallel sides in my square and I have two pairs of parallel sides in my rhombus. So I'm going to put square in the middle because my rectangle and my rhombus, they both have qualities as my square. And my rectangle does not have qualities as my rhombus because my rhombus does not have right angles. But my square does have right angles and my rectangle has right angles. So I'm going to put rectangle right here. Because again, my rectangle and square both have right angles. So that means they have similar qualities. And my square and my rhombus have similar qualities because they have two parallel sides, two pairs of parallel sides. So again, my rectangle and my square have similar qualities, which means they overlap right here because they have two parallel sides and they have right angles. And my square and my rhombus are similar because they have two pairs of parallel sides. So let's go ahead and we're going to write and explain what our diagram shows us. Now in your own words, you're going to explain our Venn diagram. So go ahead and press pause and explain in your own words. So my diagram shows that squares have all the properties of rectangles and rhombuses. So I see that my square has all the properties of a rectangle and rhombus. Now at this time, you are going to complete pages 327 and 328 on your own. If you need assistance, please be sure to view this video again to help you.